Hello, in this video we're going to go through Learning Target 432, and this is part 2, where we are going to focus on experimental probabilities. In the first video, we focused on theoretical. So up at top, this is just a reminder of how we can calculate experimental probability, and then let's jump right in. So the first example says, a spinner with 8 digits is spun 56 times. The data is given below. Answer each question that follows. So part A says, theoretically, how many times should each number be spun? So if it ever says theory, we don't actually care about how many times it actually was spun. We do it the same way that we did previously and just calculate the theoretical percentage. So theoretically, if I have a spinner that has 8 digits on it, then each number should be spun at a rate of 1, which is our hopeful outcome, that number, over 8 options. And this gives us a decimal of 0.125. Now, it did not say what's the percentage it should be or what's the probability. It says how many times should each number be spun. So we can use our probability to then predict if I do something a certain number of times, how many times my hopeful outcome will happen. So if this is my probability and I spin a spinner 56 times, I can take this probability and multiply by 56. And I get an answer of 7. So in theory, each number should be spun 7 times exactly. And if you look, that did not happen. They're a variation, but they're all fairly close to 7. So now part B gets into comparing theoretical and experimental probability. So this one, we can use it to predict how many times something should happen. This one, we're going to compare our theory to our experiment. So the first question says, what is the theoretical probability of spinning a number larger than 5? So again, in theory, we don't care how many times it actually happened. Numbers that are larger than 5 are 6, 7, and 8. So that's 3 out of 8. And I think finding the percentage is easier to compare, so I'm going to do that. So our percentage is 37.5%. And I like to label mine, so I'm going to label this one with T for theoretical. Then it says, what was the experimental probability of spinning a number larger than 5? And so this one, I do want to take into account my actual data. So a number larger than 5 is 6, 7, and 8. So I'm going to add up these 3 numbers. That's how many times it actually happened. So that's 25. So for my experimental, my number of times the event occurred is 25. My total number of trials is 56. That's how many times I spun in general. And let's figure out that percentage. So 44.6. So our theoretical is here. This is in theory how much. Our experimental is here. So it looks like experimentally I had more of the numbers larger than 5 than I really should have based on the theory. And last one, you could have a question that's like this. Is the experimental probability of spinning an even number higher or lower than expected? Expected is another way to say our theoretical. So if it ever asks you for an expected, that's our in theory value. So is the experimental probability of spinning an even number higher or lower than expected? So let's find the theoretical of an even number. So our even numbers are 2, 4, 6, and 8. That's 4 out of 8 total. So in theory, that's 50%. Our experimental, let's figure out how many times that actually happened. So 2 happened 10 times. 4 happened 3, 6 happened 11, and 8 happened 5. Add those all up together. So 29 times. And then again, our total trials is 56. And our answer, 51.8. So the experimental probability is higher than the expected. And that's it really. So we can use an actual experiment to compare to the theoretical probabilities, which is helpful. So go ahead and pause it and do the U-try, and then push play when you're ready to see the answer. So in this problem, whenever we're talking about a standard deck of cards, you should know that that means there are 52. And you do just need to know that there are 52 cards in a deck, because that's a very common probability question. So 52 cards, and we have these 4 suits. So experimental probability of drawing a diamond is at higher or lower than expected. So our theoretical is 13 over 52. So that's 1/4 because there are 4 suits. And then our experimental of a diamond is 7 over 30 draws total, which is 23.3. So our experimental is lower. And part B, what's the experimental probability of selecting a suit that is black? Those are spades and clubs. So 14 out of 30, which is 46.6%. All right, flip to the back. We're going to do another example, which is a little bit different. It's just kind of predicting or like pushing out our sample to a bigger population. Now this one says JD conducted a survey of students in his classes to determine the distribution of eye color. The table shows his results. If the distribution of eye color in JD's school is similar to that of his class, how many of the 650 students would be expected to have brown eyes? So the first thing I need to do is I need to find the probability of having brown eyes in his class. So I have brown here. I need to figure out my total number of people so I can add up all of these. And we get 80. So he surveyed 80 people. And now my percentage, my probability of having brown eyes is 58 over 80. Which is 0.725 or 72.5%. You want to leave this as a decimal or a fraction to do this next part, because now we're going to predict if this is the percentage or the probability of having brown eyes. If now we have a sample size of 650, we take this, we multiply by our bigger sample, and we see how many students will have brown eyes. So 471.25. These are people though, so we cannot have 0.25 of a person, so round this, and I use this symbol. This is the approximately symbol. So approximately 471 students will have brown eyes. Go ahead and pause it and do this U-try, and then push play when you are ready. All right, so there are 11 days total in here, so when we are tracking this, 6 or more vitamins would be these dots, which happened 5 times out of 11 total for 45% probability. If we apply that to the next 30 days, that means that approximately 14 of those days she'll be taking 6 or more vitamins. Hope this helps.